Okay, so if we follow our process air through from our coalescer after the chiller, we'll find that our big air line comes down and into this line here, where we have two big valves. The air can go in either direction, either of one of two absorber beds. So these absorber beds are basically molecular sieves, which will remove CO2 and water vapor from the process air stream. We want to remove both of those because both of those components will freeze at cryogenic temperatures inside our heat exchanger and cause blockage. Okay, so you'll see that we have two absorber beds. We call it bed A and bed B. At any one time during the running of the plant, one bed will be online. It will be a pressurized bed with the process air stream flowing through it, acting as a molecular sieve, removing the CO2 and water vapor, and the process air moving through that bed and on to our cold box and the distillation process. At the same time, the second bed will be regenerating. After a certain period of acting as an online bed, the molecular sieve material becomes saturated with CO2 and water vapor, and we need to clean the bed. The online process, as I said, is a high pressure process. Only at high pressures is the molecular sieve material effective at trapping carbon dioxide and water vapor. So for the regen bed, we depressurize that bed and we put hot waste nitrogen from the cold box through that bed, and that hot low pressure waste nitrogen strips the molecular sieve of CO2 and water vapor, which is then emitted to atmosphere through our waistline. Okay, so you'll see that there are four main bed valves, these big black valves, which control the flow of air between the two beds. These valves will direct the process air into the online bed and out of the online bed and into the cold box. They will direct the waste gas from the cold box waste into the regen bed and from the regen bed out. These four main valves are all controlled by the PLC. They're automatic valves. You'll see that each one has a solenoid on it and it has an instrument air supply. So the PLC inside our plant computer will basically send a signal to whichever valve needs to be opened. It's a digital signal which will energize the solenoid. The solenoid will allow instrument air into that particular valve and open that valve. So if we just look at the process while the plant is up and running, the in line is at the very base, and if this bed here is online, then this valve will be open. The air will be moving up through this bed and out through the top. Online out is labeled there, and to the cold box. If this is the regen bed, then these two valves will be open, allowing our regen gas from our cold box to come through this way and down in the opposite direction and through the regen out and to atmosphere. Okay, so you'll notice that each bed also has two blue valves. These are smaller valves. One is for pressurization of the bed and one is for depressurization of the bed. Before we can bring an online bed online, we need that bed to be at a high enough pressure so that there's not a huge pressure differential between the output of the compressor and the pressure inside the bed. So we slowly pressurize a bed before we bring it online. Likewise, before we regenerate a bed that was previously online, we need to depressurize that bed, and that needs to be done at a very controlled rate. So each bed has a pressurization valve with a small orifice which allows only a limited stream of air into that bed, and each valve has a depressurization valve at the bottom which likewise allows each bed to depressurize. So the normal process would be an online bed being online for about 8 hours, acting as a molecular sieve. After that period, the PLC, which is our brain of our plant, will stop the regen process of the regen bed. It will close all the main valves on the regen bed. It will then open the pressurization valve for the regen bed, slowly bring the regen bed pressure up to an equal pressure with the online bed, at which point the online valves will open for the regen bed as well. So then you will have two beds online in parallel, both with their main online valves open. There's a parallel period of about 30 minutes in which both beds are used online. After that, the PLC will close the previously online bed and we'll depressurize it. Once it's reached a certain depressurization set point, it will then open our regen valves for that bed, and that bed will become the regen bed. And so we have an 8-hour cycle in which the beds swap between regen and online functions. This is our online process air into our online bed, and you can see that you have a bypass valve that leads directly from that online line into our waste line. So this is the waste line coming from the waste gas coming from our column and going to atmosphere, and this is the waste line coming from our regen bed, also going to atmosphere. So we can bypass process air from our process air line, high pressure air, into atmosphere basically. And we would do that under certain circumstances where the plant itself was not taking much air, there was not much airflow through the plant, maybe the coal box is closed, maybe we're doing an initial bed regeneration process, maybe we're pressurizing a bed, so there's only a very small process flow being allowed into the plant. That would be on startup. And what would happen if we opened up this valve? It would just allow our compressor to push more air through the plant, which would mean that our compressor could load and unload or modulate in a slower cycle. If the plant is pretty much closed, apart from a small pressurization valve, the compressor is trying to push air through the plant. It reaches its maximum output pressure. It would then unload. So it would go through very rapid cycles or modulation cycles of loading and unloading. It's not necessarily bad for the compressor, but we would rather reduce the frequency of that modulation by opening the bypass valve to a degree and allowing the compressor to modulate in a more controlled way. Obviously, when the plant is running and we're making liquid, this valve would be 100% closed. We want all our air going through to the process and the distillation. While we're here, very briefly, you can see this manifold. There's a small manifold here with a little filter, and what this line is basically taking air from whichever bed is online. It's taking pressurized air from inside the bed through a small filter, and it is distributing it to wherever it's needed in the plant. So some of it will go to seal gas for the turbine. Some of these 4 lines are going to our main process bed valves, which are pneumatically powered. Our main trip valve is also pneumatically powered. So this manifold distributes. There's a secondary manifold as well, and from there it's distributed to wherever instrument air is needed. Right, so if you look at the piping that comes from the online bed, this is our online process air from the online bed. It first comes through a dust filter. Our molecular sieve is a ceramic material, so we may end up with a very fine ceramic dust in our process air. So this dust filter removes any ceramic dust that may be in the process air. And our process air in there moves through these 2 valves and up through this line and into our coal box. Okay, this is a manual valve. It's just an extra level of safety that we can manually make sure that the coal box is closed to the process air until certain conditions are met. And this is an automatic trip valve. This valve, flow control valve 314, will only open and allow process air through into our coal box if our lube oil system is running. In other words, if the oil lubrication system for our turbine is running. If for some reason the lube oil pump shuts down or the lube oil pressure drops below a certain set point, this valve will close. And why it does that, we do not want process air moving through our coal box with the potential to spin our turbine unless we have lubrication. Okay, so during the normal running of the plant, this line will be the waste nitrogen plant from the top of the column. And we will have waste nitrogen that comes down this line through a check valve and goes to a regen heater. Okay, the air is heated to a set point temperature, comes back out of the base of the heater and flows to our regen bed. Okay, So that's when the plant is making liquid, and we have a supply of nitrogen gas that is waste nitrogen from the top of our distillation column. It's excess nitrogen. It's a nice, safe, inert gas that we can use for heating and regeneration. It's clean and dry. But when we first start our plant up, if our plant's been down for a few weeks and it has no liquid, or we first commissioning our plant, we don't have a supply of nitrogen. So what we do is we use this startup valve, V365, to take some of the incoming process air in a short cycle bypass line, and we take that air and we put it into our heater. That's as an initial regeneration process. The other line which you will see, which may cause some confusion at first, is this line here. And this line is a line that we can use only for thawing the plant or deriming the plant, and it allows us to take hot air from the heater with a modified set point so that it's not too hot, and to put that air into the process air line so we can put hot air through our column. Okay. You can also thaw and derime the plant without using hot air, because the air that's moving through the online bed is so dry that you don't really need heat to thaw the plant. But if you would like to use that function, there is a hot thaw function, and this is the valve that you would use to do that. You'll notice here we have a flow switch. It's a pressure differential switch, PDS 305. And this switch basically looks at the differential pressure across the heater, the pressure at the start of the heater, the pressure at the exit of the heater. And it acts as a flow switch which makes sure that we have an airflow through our heater, either a process airflow from our startup valve, or we have a flow of waste nitrogen moving through our heater. And without a flow of nitrogen or air coming through our heater, this flow switch will make sure that the heater does not turn on, okay, unless we have that flow. So it has a set point. The orange needle in the valve shows that that's the set point. The black needle is the actual process value. The black process needle will need to be above the orange needle in order for the switch to activate and allow the heater to turn